Hi everyone, welcome to online lecture 22, and this will be your exam 2 review. Okay, so let's start off with a couple of easing into exercises here. So a statistics major was completely exhausted the day of his final exam. It was a true-false test, so he decided to flip a coin for the answers. The statistics professor watched the student the entire 2 hours as he was flipping the coin, writing the answer, flipping the coin, writing the answer. At the end of the 2 hours, everyone else had left the final except for the one student. The professor walks up to his desk and interrupts the student saying, "Listen, I've seen that you did not study for the statistics test. You didn't even open the exam. If you're just flipping a coin for your answer, why is it taking you so long?" The student replies bitterly as he is still flipping the coin, "Shh, I'm checking my answers." Ba-dum-bum. Okay, moving on. The tattoo parlor near campus got busy when the professor required hand calculation of the standard deviation. Okay, so comments actually on the first and second one. For the first one, it is in your best interest, of course, to answer every question. It is not true false, but still, just give it a shot, even if you don't know, because you're only the only thing that can happen is that you potentially give yourself more points. So that's my advice there. Here, remember, I do give you a formula sheet. In fact, it's posted on D2L for you, so you do not have to actually get a tattoo of the of any of your formulas. Okay. Even though you are a statistician, Mr. Phelps, I can't allow a deduction for your dependent variables. Okay. So even though we talk more about independent and dependent variables on exam 1, that's the kind of topic that you want to hold on to. Because it's still going to be relevant. You're still going to have to know which is which in order to set up your formulas for exam 2. Okay. Interpreting the Z and T tests. Now this is critical. That's why I decided to review it. There won't be, this is the main thing I want to review with you. If you're doing a hand calculation, right, if you're not using SPSS, to reject the null hypothesis, the calculated t-score needs to be more extreme, further in the tails, further away from 0 than the tabled value. If you're looking at SPSS, to reject the null hypothesis, the observed p-value or sig value needs to be less than alpha, right? And what's our good old exception to the rule? If you have a one-tail test with results in the opposite direction of what you predicted of the alternative hypothesis, you will not reject the null hypothesis. It could be way extreme, but in the wrong tail. It could be a very low P, but if it's in the wrong tail, you won't reject. Okay, it might be very significant, but you won't reject. Okay. Now we get into the heart of the matter. The following 5 questions are examples of the sort of questions that could be asked on the exam. At least one of these 5 questions will appear on the exam. Consider a study in which the sample variance estimate based on a treatment group of 8 participants is 60, and the sample variance estimate based on a control group of 17 different participants is 42. Compute the pooled variance. One thing to note here is that they all have 1 decimal after them, so we don't have to really worry about the rounding rule here. I also didn't tell you what the original data looked like, so we're just trying to do a calculation here. Okay, so I invite you to pause, do that calculation, and when you would come back, I will tell you that the answer is A, 47.5. Okay, so how did we get that? We took 8 minus 1, which is 7, times 60. And then we took 17 minus 1, which is 16, times 42. We added those two numbers together for 1,092, and we divided by 8 plus 17 minus 2, right? Because this would be n1 plus n2 minus 2. So that would be 23. So we take the 1,092 divided by the 23, and we get 47.47 something else, which rounds to 47.5. Okay, so like I said, that you didn't have to apply the rounding rule at all. Once you saw the 47 point whatever, you should know that it was A. Okay. Okay. The distribution of snow leopard weights is known to be positively skewed. A very, very brave ecologist decides to weigh wild snow leopards. He measures 120 samples with 70 snow leopards in each sample. According to the central limit theorem, what do we know about the distribution of the mean snow leopard weights? Okay, so this comes really directly from that video we watched together during the lecture. And I will tell you the answer in just a second. Okay, so it's B. It will be approximately normal with a smaller, narrower distribution than the population distribution of individual snow leopards. Okay, so that's what the central limit theorem tells us, right? Even though it was positively skewed because our sample size, we had enough samples, we had 120, and our sample size was greater than 30, it was 70 in each sample, then we know it's going to be normal and narrower. Okay, those two kind of go together with the central limit theorem. All right. Janice believes that she has developed a new therapeutic approach that will increase self-esteem. She obtains 2 samples of persons with low self-esteem. One group receives her new treatment and the other group receives the old treatment. Self-esteem scores are obtained after the treatment. The alpha has been set to 0.01. What is the numerator for the appropriate Z or T score? Okay, so I want to stress that we're only looking for the numerator here. And if you remember, when we were kind of going through and looking at all the different Z and T tests, that the numerator is always the subtraction of means. The only question is, which means? Okay, so if you've now solved the problem, I will tell you that the answer is 8 minus 5, or choice B. So why was it choice B? Well, because this was an independent samples t-test. I know it said new and old, and that might make you think of pre and post, but it was clear that one group receives the new treatment, the other group receives the old treatment. We have 2 separate independent groups. Okay, so what is that? It's x bar 1 minus x bar 2. And if we took the mean of the new treatment, we would get 8. If we took the mean of the old treatment, we would get 5. If you chose D, 3 minus 0, that means you thought it was a dependent samples t-test, I suspect, and you looked at the differences. So you did your calculation right, you just did it for the wrong test. Okay. All right. Marcel has found that the employees in his division watch an average of 27.8 hours of television per week, with a 95% confidence interval of 25.7 to 29.9. Which of the following would be an appropriate statement about the confidence interval? Okay, so first thing I want to notice is that these all say 95%. These all say 25.7 to 29.9. So that's not the key here. The key is in the wording. This isn't a calculation problem. This is a wording problem. So the only differences are probability versus confident and mu versus x bar. So which is the right combination? And I will tell you now that the answer is B. We can be 95% confident that mu is between 25.7 and 29.9. So whenever we're talking about confidence intervals, we're talking about the word confident, look for that. And we're always talking about, we're trying to estimate mu. We're not trying to estimate X bar. We were given X bar in the calculation of the confidence interval. We're trying to estimate mu, excuse me. Okay. Which of the following would decrease the effect size? Which of the following would decrease the effect size? Once again, another theoretical question. And now that you've paused and come back, I can tell you that the answer is D. D. Increase the differences between means of the groups and decrease the variability within the groups. And that's, again, something else we talked about in the lecture. You're trying to, if you're trying to, excuse me, that's totally wrong. Sorry about that. We're trying to decrease effect size, not increase effect size. So it would be the opposite of that. It would be decrease the difference. It would be C, decrease the differences between means of the groups and increase the variability within the groups. So again, that would be C, decrease the differences between the means of the groups and increase the variability within the groups. So there you go. Classic example why it's good to carefully read the question, maybe even go back and read it a second time. So when we're decreasing the differences between the means of groups, that means our groups are going to be closer together. And same with increasing the variability within the groups, you're going to have more overlap. And effect size is all about overlap. So if we have things closer together, if we have more overlap, we're going to have decreased effect size. Increased effect size is when they're more spread out, right? There's more of a difference between the two. Okay, so had it been increase effect size, it would have been D. Because it was decrease effect size, it was C. Okay, all right. So let's talk about some symbols. Mu or mu D is your population mean. X bar or D bar, sample mean. Sigma squared, the population variance, and sigma, your population standard deviation. Any form of S squared is your sample variance, and any form of S has to do with sample standard deviation. Whenever you have the funny little symbol of X bar sitting beneath your symbol there, you've got a standard error of the mean. Right, so any of those, sigma of X bar or S of X bar or S of D bar or S of X bar 1 minus X bar 2, all standard error of the mean. N, if you recall, is your sample size. SS is your sums of squares. DF is your degrees of freedom. Next symbol is your alpha. Next symbol is your P or probability. And then Z-score or Z-test, T-score or T-test, and finally, summation. So those are, I tried to compile a list of the symbols I think you would potentially encounter on exam 2. If there's any other symbol that you struggle with or not sure maybe make it part of your note sheet. And that brings me to my next point. The note sheet is required for this exam. Okay, I think most of you did it last time, but some of you didn't. But this time it's required and it's worth 5 points. So just by putting together a nice note sheet for yourself and submitting it, you will get 5 points on this exam. Okay. That's all I have for you for today. Stay safe, be well. I'll talk to you next time.